Quite often, we want to start a task upon completion of another task. For example, let's say we have the ID of a user. Now we want to get the user's email. So we have to go to our database and read that user record. With this, we can get their email. Now, we want to pass this email to one of those music streaming websites where people have their own playlist. So we pass the email and get the playlist for a given person. So here we have two tasks, two asynchronous operations. We want to start the second task upon completion of the first task. Completable features make it really easy to implement these kind of scenarios in a declarative and efficient way. Let me show you. So first, we're going to create a completable feature for getting the email of a user. So completable feature.supply async. We pass a lambda, and here we just want to return the email for this user. In a real-world application, in the body of this lambda, we're going to query a database. But here, I just want to return a string. Now, this returns a completable feature of string, right? So completable feature of string. Now, we want to start the second task upon completion of the first task. To do that, we call feature.thenCompose. Now here we should pass a function that maps a string to a completion stage object. That means from this function, we should return a new completable feature. That completable feature represents a new asynchronous task, right? So what is the string that we get here? That is the email that is returned from our first task. So we get the email. Now we want to pass this to a second task. So here we should return a new completable feature object. That is very easy. So completable feature.supply async. Here we should call that remote service to get the playlist for this user. So we pass another supplier object. With this supplier, I'm going to return this string, playlist. Now, in a real application, we're going to return a playlist object or a list of songs. But here, I don't want to waste time creating different classes. I just want to return a string. All I want you to understand is that our first task returns an email. Then we pass the email to our second task and get the playlist, okay? So when we call thenCompose, we get a new completable feature. So here we can chain another method like thenAccept. We get the playlist and print it on the terminal. As simple as that. Now, let's reformat our code. So let's put each method call on a new line. That is better. We don't need the comments. Let's run our program. So we get the playlist. Beautiful. Now, let's improve this code further. Technically, we don't need this future variable. We can immediately call this method on the object that is returned over here. So let's get rid of the future variable. So we call completable feature.supply async. This is better, but we can make this even better. What is this lambda representing? It's representing a task for getting a user object from a database. So in a real application, we would probably have a method somewhere like public, in this case, static. In a real application, we would return a user object, but here I want to return a string. We call this method getUserEmail. Now, I told you that querying a database is a long-running operation, so we should make our APIs asynchronous. So instead of returning a string, we should return a completable feature of string. Now, inside this method, we're going to have some code for querying a database and getting someone's email. So we return completable feature.supply async and return this email. Okay? Now, with this method, we no longer need this piece of code over here. We can simply call getUserEmail. Also, as I told you before, it's better to use the async suffix here to indicate that this is an asynchronous method. So let's rename this to getUserEmail async. Now, we're going to apply the same technique over here for the second task that gets an email and returns a playlist asynchronously. So in a real application somewhere, we're going to have another method for getting the playlist of a given user. So public, static, we have a long-running operation, so we should return a completable feature of, in this case, string. And we call that method getPlaylist async. Now here we need a parameter of type string called email. So this method gets the email of a user and calls a remote API to get the playlist for that user in an asynchronous fashion. Now here we should return a completable future that's supply async, and we return this playlist, right? Now with this refactoring, we no longer need this lambda over here. We can use a method reference. So the name of this class is Completable Futures Demo. I'm going to type that here, Completable Futures Demo. Then we have colon, and finally get playlist async. Now look at the end result. We're getting the email of a user in an asynchronous fashion. Then we're composing this with another operation for getting the playlist. And finally, we print the playlist. This is the beauty of completable futures. We can build this kind of complex asynchronous operations in a declarative way.